Hi folks, today we're going to do the importance of measurement. Measurement is something that is extremely important in chemistry. We have two types of measurement. We have qualitative versus quantitative measurements. And you should be able to just think of the word quantitative, that's the second word you're looking at down here, right? And you should be able to say, what does that mean? Well, quantity means numerical. So that one should be pretty obvious. And qualitative is the other one. It means quality. It's descriptive. So when I measure something, I can either I can either measure it numerically, or I can measure it kind of as a descriptive statement. So for example, this might be something is hot, and this might be it is at 400 degrees Fahrenheit. Right? That's the difference. Descriptive means hot. Well, what is hot? We don't really know. Right, but numerical gives you a number. Okay, so that's the way to tell the difference. So the stove is hot. The oven is set to 350. The first one is qualitative, and the second one is quantitative. And the reason you can tell it's quantitative is you look right there, and that gives you a quantity. The ice is cold. Mount Washington is 6,288 feet high. That's a quantity. Right? Cold is qualitative. John is sleepy, again, qualitative. Water freezes at 0 degrees Celsius, that is quantitative. Again, you have a number, you have a quantity. Okay, so hopefully you noticed that. That's the way you tell the difference. All right, so go ahead and try these. I'll give you a minute. Pause the video, do them, and then come back. Okay, house is yellow, qualitative. There are no numbers. Frank is 17 years old. That is a number, so it is quantitative. 3 hours, Paul studied. That's a quantity. The dog is barking loudly. That's qualitative. He likes rock and roll music. That's qualitative. He has 94 rock and roll CDs. That's quantitative because he has a number. Jill's tired. Now qualitative and quantitative again for 38 straight hours. All right. Now I'm going to do a very quick refresher on scientific notation. If this is too quick for you, go back and look at Unit 1. Look up scientific notation again, where I have spent a little bit more time on it. Right? If you remember, when you have a number in scientific notation, you have a number like 4,592, and you're going to convert it to scientific notation. The rule is you may only have one non-zero digit prior to the decimal point. So it's 4.542. And I have to multiply that by a number. Now you'll notice there's an implied decimal point here that I moved 1, 2, 3 positions. So this is going to be times 10. And the question is it times 10 to the third or 10 to the minus third? Well, when you look at this number, it's 4,592. That's a big number. So what I did was I took 4 and I multiplied it by 10 to the third, or 1,000, to come up with this. So I moved the decimal point 3 positions, but because I'm multiplying by 1,000, it's 10 to the third. It's a big number. Similarly, if I have 0.004592, I'll use exactly the same number. This is also 4.592, again by the same token, because you have one non-zero digit before the decimal point, and I have to move the decimal point 3 positions. Okay, so this is again going to be times 10. I'm going to have a 3 up here, but this time, because this is a very small number, it's less than 1. This is going to be to the minus 3. Right? Of course, if I go the other way, 3.79 times 10 to the second. Now let's make it times 10 to the fourth. Times 10 to the fourth. Then I have to move my decimal point 4 positions over to the right because I'm multiplying by a big number, in this case 10,000. But I don't have enough digits, so I have to make some up. So what does this tell you about these two numbers? We're going to talk eventually about significant digits. Well, these two digits, I made them up. They're not real, but I made them up. But I needed them for placeholders because I had to take my decimal point and move it 4 positions to the right. All right, 6.92 times 10 to the minus 5th. Well, again, I have to move my decimal point 5 times, but in this case, I'm multiplying by 10 to the negative 5th, so I'm multiplying by a very small number. So I have to move my decimal point 5 positions to the left. So I end up with 0.0000692. All right, that's your refresher on scientific notation, on the basics of it. If we're going to add two numbers in scientific notation together, we have to make sure that when we do that, we make the exponents the same. So if I have 3 times 10 to the, let's say, second, and I add that to 2 times 10 to the, let's say, third, what does that come out to be? Well, let's just do it with regular numbers first. 3 times 10 to the 2 is 300. 2 times 10 to the 3 is 2,000. And you'll notice I come up with 2,300, which is 2.3 times 10 to the third. Well, let's do it the way you're supposed to do it. The way you're supposed to do it is these exponents need to be the same. So it really doesn't matter whether I go to the 3 or whether I go to the 2. I have to pick one. Right, let's just go to the 2 just because that makes it a little bit more difficult. So if I want to make this times 10 to the 2, I'm only multiplying by 100 instead of 1,000. So that means this number over here is smaller. I've gone from a 3 to a 2. That means this number has to be bigger, so it's going to be 20. And this is still 3 times 10 to the 2. If I add those together, times 10 to the 2, plus 20 times 10 to the 2, that becomes 23 times 10 to the 2. Well, that's not proper scientific notation, which means I have to move my decimal point 1 position to the left. I make that number smaller, 2.3, and that means I have to make my exponent larger. So it's 2.3 times 10 to the third, and you'll notice that's exactly the answer that I get over here. So my answer is correct. Now, whether you're doing addition or subtraction, the math works exactly the same way. You still must make your exponents be the same. Right? Now, you'll notice I'm not adding my exponents, subtracting my exponents, anything like that. They have to be the same. So when I add the two numbers, I'm adding the coefficients, which are over here, to make 23. And my exponent just comes down and remains the same as 10 to the second. Subtraction works exactly the same way. Again, if you're stuck on this, not sure, go back and look at Unit 1 again. All right, how about multiplication? Multiplication, if I have 2 times 10 to the third, and I'm going to multiply that by, let's say 6 times 10 to the fifth, what am I going to get? Well, the way this works is you take your coefficients, the 2 and the 6, and you multiply them. 2 times 6 is 12. And you take your exponents, which are 3 and 5, and you add them. That becomes 10 to the 8th. Now, you're almost there, but this number right here is not in scientific notation. So I have to move my decimal point to my left to make it 1.2. And that's going to make this number on my left smaller, which means I have to make my exponent larger. So it's 1.2 times 10 to the 9th. Okay? Now, the other thing to do is division. So if I have 2 times 10 to the third, and I divide by 6 times 10 to the fifth, well, you should be very familiar with the fraction 2 over 6, which is the same as 1 over 3, which is 0.33333, repeating, and it goes on forever, times 10 to the, well, we have 3 divided by 10 to the third divided by 10 to the fifth. We subtract, so we take 3 minus 5, and we come up with a minus 2. That's a minus 2. Well, again, we're almost there, but we notice our decimal point isn't in the right position. We have to move it. So that becomes 3.33, and that repeats. But I've made this, the coefficient, bigger, so I have to make this number smaller, 10 to the minus, so I have to make this further away from 0, so that makes it smaller. So it becomes minus 3, so that's my final answer. Right. So there you've got multiplication and division. Again, guys, if this is confusing, go back and look at Unit 1 again. All right. There are also some videos out there by Sal Khan. We'll talk about that, and I'll reference it here. www.Khan Academy, and that's Khan, Khan Academy.org. And he has some great videos out there on scientific notation, on chemistry, on all sorts of stuff. So all year I'm going to refer to Khan Academy. Sal Khan, he's got some good resources out there. If you get stuck on something I've done, that's a good place to look. All right, graphing. I'm not going to spend any time on graphing. You do need to know things like y is equal to mx plus b. That is your slope-intercept form. This m here is going to be your slope. And if you remember from Unit 1, this is rise over run. and your b is going to be your y-intercept. So you need to be able to apply this to looking at graphs. I'm not going to spend any time here doing it. Again, you should have mastered this in Unit 1. If you're stuck, go back and look at Unit 1 again. All right, I'm not going to do it here. Very quick algebra refresher. Remember that if you have a couple of things multiplied by each other, like AB equals CD, and I want to solve for C, I want to get C all alone by itself, I divide both sides by D. D will then cancel over here on the right. I'm left with C all by itself, and I'm left with AB over D. If I have xy, x over y equals, well, let's say A over B, and I want to solve for one of my unknowns, then the easiest way to do it is cross multiply. Let's say I want to solve for B. Then I take the A times the y, and I divide by what's left over, which is the x. Let's make that a little bit more complicated. AB over C equals DE over F. And I want to solve for D. Well, I look at D, and I tend to circle this just because I know what I'm looking for then. And I say, well, here I have to cross multiply. So I look at the ABF, and I put ABF on top. And I divide by what's left. What's left is the C and the E. So the C and the E go on the bottom. And I didn't have to do a bunch of algebra to do that, but that is, algebraically, that's the way it's going to work. And so that always works. So just a quick algebra refresher. Again, these are things that you should know back from Unit 1. Okay. Let's do one more. AB over C equals xy over z. And I want to solve for z. I want to get z all by itself. All right? So why don't you pause the video, see if you can figure out what it's going to be. All right? So we have c all by itself, so I'm going to cross multiply. I'm going to look at these things over here. So that's c, x, and y because they're opposite to me. All right? And then I come across here to find the a and the b. And that's what's left over. So that's how I solve for z. The fact that it's in the denominator doesn't make any difference if I'm doing cross multiplication. All right. Again, if you need help, go back to Unit 1. Watch Sal Khan on khanacademy.org or see a teacher. You need to master this. You're going to see this all year. All right? And so if you need my help, please come see me, and I'll be more than happy to help you. All right. You've got qualitative and quantitative measurements, scientific notation, and algebra. Oh, yeah, and graphing. Didn't put that in there, but you need to do graphing as well. All right? Hopefully you took notes. I'll check them in class. We'll see you then. Have a great day. Bye.